Organic chemistry, benzene reactions. I will start today. Right? Chemical reactions of benzene. Aromatic. I just started benzene. I told you the structure of benzene and everything, and today we had do the reactions of benzene. Now under hydrocarbons, alkanes, alkenes, alkynes done. I gave the summary also the reaction. Benzene also we have done the structure of benzene, Kekulé structure and all we have done, right? And hybridization. And did I discuss? I think I discussed this also. If not, I'll discuss this today. Okay, before all, so I have sent a link to your chat. Can you see the link? Did you all get? So can you now that is a new app I am using from today onwards for the every day. Before I discuss the theory, I'll ask you questions from the previous lessons, and I'll be using this Mentimeter for the evaluation and assessment also. Like I can do online, I mean evaluation, maybe a small like a paper. Then I can check whether you can remember the previous lesson, as well as I can at each chapter I can do a small test using this app. You can click on this. I have sent the link to your chat. You can click on that. No need to download this app. It's online. There are 5 questions I have put, like just start. I mean, please raise hand those who have used this app before. Mentimeter in school or anywhere. No one, right? Has anyone used Mentimeter? No. Okay, then you can click on this link on the chat. I have sent that link to the chat. You can click on that, then you can answer the questions, right? You can answer the questions, and then once you finish all 5, I have given just 5 MCQs from the previous lesson. So once you complete, once you submit that, you can come back to the Zoom again. No need to sign out or no need to leave from the meeting. It's within the Zoom platform, right? It's a Zoom app, right? So can you start? Once you are done, you can raise the hand before we start the today's work. I'll share the screen also. Right. You can start that. Right. Tamasha, I think she has left. Did did you all open the link? Only 3 of you have joined. You can go to the next slide. Once you're done, you can go to the next slide. Click on next slide. You can see the next question then. We'll get about, go to the next slide. Right. Question number 3 also you can try. I have not limited the time, so otherwise I can. Right, very good. Only one has done the third question. Right, done all. Right. So, right, okay. One more to do. Okay, done. Then next question. Question number 4. You can hear me, right? Okay. You can do the fourth question also. Two more to do the fourth question. One more to do the fourth question. Next time I'll set this to put your name also, then I can see your name also. Now, this one more who has not done this fourth question. Did you do the? So one has not done the fourth MCQ. Okay, I'll move to the next question then. Which of the following reaction can be used to distinguish alkenes from alkanes? This can be used to do like it's repeated, so you can omit that, the last 3 words. Okay. There's one more to do the last MCQ. I think someone has not joined out of the last 2 questions. Only 3 of you have answered the last 2 questions. Right. Now you can come back to the, if we are done, if we have submitted all, you can come back to the Zoom meeting again. Can you see the screen? Can you see the first question? I'll discuss now. Right. Okay, so the first one, the main characteristic reactions of alkenes. Did you all come back to the again Zoom? Everyone? Right. Okay, now can you can see, right? Can everyone see the screen? Okay. The first question I asked, the main characteristic reactions of alkenes. So I think only two of you, 50%, like, who didn't answer this? Only two of you have answered this. Electrophilic, answer is what? Electrophilic addition. Alkenes, the main type of reaction, electrophilic addition. Please raise the hand who has done this. All four of you have done. Okay, good. So answer is fourth, right? Very good. Electrophilic addition. The next question I asked, hybridization of carbon atoms of benzene. Hybridization of carbon atoms of benzene. So benzene, all 6 carbon atom what hybridize. Now this one 100%. All 4 have put sp2 hybridization. Good. If you want, I'll press this, then you can see the answer is what? Second. So the others get like blurred, and then answer is you can see second one is highlighted. That is the answer. Everyone has answered that second one. Very good. Then next question number 3. Question number 3. So this one, 2 of you have answered free radical substitution, and 1 of you have answered free radical. I have repeated this, free radical substitution in two places. Okay. It's small. There are 2 similar answers. Okay, then both are correct. So 1 of you have answered electrophilic addition, right? So the answer is free radical substitution. Alkanes like chlorine free radicals in the presence of light. So at the very beginning we did this reaction. It is free radical substitution. Chlorine radicals come and replace hydrogen of the hydrocarbons. So alkanes. So actually electrophilic addition, that is for alkenes. Who answered this third one? Who did the third answer? Can you please raise the hand? Okay, Vinhara. Right. So electrophilic addition, that is alkenes. Okay, alkanes main characteristic reaction will be free radical substitution. Right. The next one, question number 4. The previous question, the answer is, then both can be taken as the answer, right? So it's first one the answer, but fourth also I have given the same answer. Therefore, both 1 and 4 can be taken as the answer. Next one, question number 5. Question number 4. Question number 4. Which of the following organic compound of the same relative molecular mass has the highest boiling point? So I told boiling point depends on what? Relative molecular mass. So it's equal here. Then number of and the strength of intermolecular forces. Number of intermolecular forces and strength of intermolecular forces. Right. Then the answer will be actually 3 of you have put the correct answer. 67% or 33%. That means alkyne. Answer is sorry, 1 of you have put alkyne. The other one put actually answer is okay. I'll press the so now you can see the answer is 4, right? So the other 3 answers, 4 answers become it get blurred, but the 4th answer you can see it's that is the correct answer. Alcohol, if you want to write alcohol, main intermolecular force will be hydrogen bonding. Alcohol has hydrogen bonding. Can you please write, put a curly bracket to everyone? The first 3 actually London forces or dispersion forces. Alkane, between alkanes, London forces. between alkenes also London forces, between alkynes also London forces. And alcohol, right, hydrogen bonding, alcohol hydrogen bonding. And aldehydes, right, dipole dipole interaction, because between aldehydes no hydrogen bonding, right everyone. Between aldehydes no hydrogen bonding, but aldehyde with water can form hydrogen bonding. Now if you take alcohol, among alcohol also hydrogen bonding present. And if you put alcohol into water, then between that also hydrogen bonding present. That means alcohol hydrogen bonding. So look at the screen, you can see the screen, right, hydrogen bonding. But aldehydes dipole dipole interaction. So which one is more stronger, hydrogen bonding or dipole dipole? Actually hydrogen bonding also type of dipole dipole interaction. So hydrogen bonding more stronger than dipole dipole. That's why the alcohol having highest higher boiling point out of these four. You can write separately among alcohol hydrogen bonding, plus when you put alcohol into water, alcohol dissolve in water due to hydrogen bonding. Alcohol and water also hydrogen bonding there. Among alcohol also hydrogen bonding, with water also hydrogen bonding. But if you take aldehyde with water, hydrogen bonding present, hydrogen bonding present. Therefore, but with the increase of the relative molecular mass or with the increase of the carbon chain, the solubility decrease. Alcohol and water hydrogen bonding, aldehyde and water also hydrogen bonding present, right? But among aldehydes no hydrogen bonding, then is dipole dipole. Is that clear? Right. Therefore organic compounds, they can ask water solubility, boiling point, the physical properties sometimes they ask. Now we haven't done all the organic compounds set, but alkane, alkene, alkyne, alcohol we have done. And aldehyde and ketone also I think I explained under IUPAC nomenclature for everything done, right? So then that is about the question number 4. I'll erase the screen. Then next question we did the last question, I think that is question number 5. Question number 5, I asked what, which of the following reaction can be used to distinguish alkenes from alkanes? So this part you have to omit, the last okay, you can see the screen now. So here who answered this? The fourth one. Who did the fourth one? Free radical substitution. Pramudi, okay. Pramudi, free radical substitution by whom? By alkanes, but that is no direct observation there. That is by alkanes only. But the problem is main characteristic reaction, but there's no distinguish observation. So they are asking to distinguish. That means a chemical test. They are expecting a chemical test. Chemical test, right? So then the answer is bromination. Bromination is what? When you put alkenes, if you want, I'll write the reaction. So if you take alkenes, see, now this is the answer is third, bromination. CH2, double bond CH2. If you put Br2, liquid bromine with carbon tetrachloride in nonpolar medium, then what happen? We call it bromination. Bromination. Then Br is added. Br2 is added here. This is called electrophilic addition. Br2 is added and 5 bond is broken down. But with alkanes, no such reaction. If you put alkanes, I'll take CH3-CH3, C2H6, then what happened? If you put Br2, no reaction. Alkanes can react with Br2, but in the presence of light. If you put liquid bromine, no reaction. Alkanes are unsaturated. Since unsaturated, that means there's a double bond, 5 bond. Because of the 5 bond, alkenes are unsaturated. Then bromine, the brown color get decolorized due to this reaction. Brown color of bromine gets decolorized due to bromine, but with alkane no color change. So that means distinguish means a chemical test, right? Therefore the answer will be for this the fourth question. So that is answer will be third. Answer will be third. Now third one, you can see it's highlighted, others become blur. Any questions? are you comfortable with this? Because straight away going for a test is not fair, no? So you should get familiar with the method. That's why, as a, like, just to start this, I gave these 5 MCQs from the previous organic theory, and I can make different type of questions using this app. It's a very good app, inbuilt app within Zoom platform. So in upcoming classes also, every day I'll use a few questions like this to recall your previous lesson, right? Whether you can remember the previous lesson. Plus, for evaluation, this is a very powerful tool. I can time even. I didn't allocate time today, but I'll assign the time also for each MCQ, depend on the question, or if it's a calculation, I'll allocate more time. Otherwise, I can make even 30 seconds or 1 minute. Then it will be automatically close if you don't answer. Right, then I can evaluate also. Next time I'll set you to put your name, then I can see who has done the third one, and I don't need to, then it's easy for the discussion. So are you comfortable with this? So did everyone get it? Like the, right. Okay, I don't know whether you are comfortable with that posting the answer to the chat or with this one, but anyway, MCQs that as well as essay type of structure also we can do this, right? Okay, then with time you will get, today I did only the MCQ type questions, then the other modes of present in this I'll discuss one by one from next week, right? Okay, then we'll back to the lesson again. I'll erase this. Right. Then let's move on to the paper today. First, at the beginning, I will use benzene reactions, and after that, I'll come to the paper. Right? I'll discuss the theory part, small theory part, summary of benzene reactions, and after that, okay, you can see the whiteboard. If you want, you can download this the free version of this Mentimeter. There's a paid version also. I had to use the paid version, but the students can use the free version, and you can sign into Mentimeter app. If you want, you can download and sign it, and then when you do the questions, I can see. I'll give the instruction later if you want. But anyway, to do these questions, no need to download. It's online. No need to download the app. Right. So as you did today, you can do it, but if you don't get. Then because you can pass the message to the others also, right? So let's see the reactions of benzene. Now can you please tell me, did I explain this benzene, why this Kekulé structure was rejected for benzene, and okay, can someone tell me okay, you can see the screen, right? Did I explain this graph? Why out of the two proposed structures, why this one is more accepted than this is called the Kekulé structure. Highlight this. So I'll highlight. This is the proposed structure, and this is the Kekulé structure. Sorry, this is the Kekulé structure. This is the Kekulé structure proposed by Kekulé scientist, and this is the actual real benzene. Did I explain this, Pramodi? There are two proposed. Yes. Okay, right. Okay. So I have given this graph. Can you remember I gave a paper also. In that paper also you can see this 2000 organic benzene. I think, yeah, that one, benzene. The structure of benzene. aromatic organic compounds. Yeah, this one. If you want, if you have got the resource book, you can use that one, or else you can go through the. I have given a graph here. Can you see here? I have posted this to your WhatsApp. I have posted this to your WhatsApp. Now you can see this is the if you take hydrogenation, so we call it Kekulé structure, right? Kekulé structure means there are three 5 bonds alternative like this in the benzene ring, but this is called the hybrid resonance. Hybrid resonance means this one. That means there's no distinction. I mean 3 sigma bonds, so that's why we put a ring here. That is for the hybrid resonance, right? Hybrid resonance structure, resonance hybrid of benzene. Resonance hybrid. So those are the first they propose this Kekulé structure. But actually when they if Kekulé structure has 3 5 bonds like this, it should undergo what? Bromination. So it should be unsaturated organic compound. So then what happens when you put bromine to benzene, it should decolorize bromine. Bromine should get decolorized, but that didn't happen. They didn't observe this. Then you should get here bromine like that, and then like in alkene, bromine should get added. That means bromine should get decolorized, but they didn't observe. They didn't observe this. Right? This you get Br like this. So all 3 5 bonds are broken down, then Br get added. Don't forget there on each carbon the hydrogen is available, right? Hydrogen is available. I think I don't know how many of you get absent when I explained the aromatic hydrocarbons, or aromatic I mean benzene. The structure I explained in the previous lesson. Now, but that so if benzene has 3 5 bonds, that didn't happen. Therefore, this Kekulé structure was not accepted. So in the nature, what really exists, the real benzene is resonance hybrid. That means what? These 3 undergo resonance stabilization. That means what? This bond shifted to here, and this bond shifted to here, and that means the position of the double bond can, that means 5 electrons can get delocalized. 5 electrons can get delocalized. Then what happened? You get the resonance structure. We call it resonance stabilization. That means this 5 bond, it's get transferred to the next position like this. Therefore, the most accepted one was the resonance. Actually, this 5 bond won't exist as it is. It can undergo resonance stabilization. Resonance stabilization, the position of this 5 bond change due to the transfer of electrons. Like this, I will show the arrows. Now here the double bond is shifted to this one, and here it's shifted here, and here it's shifted here. Right? So this is we call it the 2 resonance structures for the benzene. Kekulé structure undergo resonance stabilization. Therefore, the real benzene is like, since the 5 bond is actually this unhybridized p orbital undergo lateral overlapping. Unhybridized p orbital. Now, if I draw this structure, on each carbon there's unhybridized p orbital. There's unhybridized p orbital. So sp2 hybridization, sp2 hybridization each carbon. So there's a unhybridized p orbital. This unhybridized p orbital on each carbon, they undergo resonance stabilization like this. Resonance stabilization like this. Like this. Above the plane also, and below the plane you get it undergoing, that means this overlap, 5 electron cloud overlap, and then you get a ring. So that's why we put a ring here. In the real benzene we put a ring inside. That means ring means 5 electron cloud. 5 electron cloud. They laterally overlap. Electron cloud. So therefore real benzene, these 5 bonds, 3 separate 5 bonds do not exist in the real benzene. So that they have proved, that is one evidence. So you can write here why the Kekulé structure was rejected, because Kekulé structure it does not answer the bromination or unsaturation test. For unsaturation it fails. So this 5 electron cloud is very strong, difficult to break down. So this 5 electron cloud resistant for breaking. it is resistant undergoing any change because this is resonance stabilized. Now it's difficult to, now this 5 electron cloud you can't break by putting bromine because it's very stable, because all 6 unhybridized p orbital laterally overlap, then it's very strong rather than just single single 5 bond. Now they have proved this. If there's if you take one single 5 bond, you can look at the first reaction. Hydrogenation enthalpy, it is exothermic, minus 120 kilojoules per mole. Then if there are 3 5 bonds, what happened? This should be multiplied by 3. Then for 1 5 bond hydrogenation, it's 1 minus 120. Then if there are, according to the Kekulé structure, benzene has 3 separate 5 bonds. So then all 3 5 bond, what happened? When you we call it cyclohexane. So then you get here hydrogen, because this also has hydrogen, right? All these contain hydrogen, 6 hydrogen. That means C6H6. So that is the benzene, C6H6. C6H6. What is the formula? C6H6. C6H6. This is benzene. So this is a, so then what happened? If you add 3 hydrogen here, 3 hydrogen, then you get what? So you get hydrogen here. You get hydrogen. So all 3 5 bonds are broken down and you get hydrogen here. Hydrogen. So the other hydrogen is already there. This hydrogen is already there. The previous one. Right. Then what is called? C6H12. Now C6H6 become C6H12. C6H12. So this is, now it is not benzene. After hydrogenation it become cyclohexane. The benzene, if you only can copy down this additional information in your organic chemistry writing book, this is called cyclohexane. Cyclohexane. Cyclo means there's a ring structure. It's not a linear one. It's not aliphatic. Now it's still, but it's aromatic. There's a ring structure. Carbon atoms are interconnected like a ring, and it's hexane because 6 carbon, and is cyclohexane, then 12 hydrogen. But if you take normal alkane, it will be what? CnH2n plus 2, then it should be C6H4. C6H14 will be just hexane. Now can you see the difference? If please copy down this. Number 1 benzene, C6H6. Number 2 cyclohexane. Number 3 hexane. Hexane means what? What is the common formula of alkane? CnH2n plus 2. CnH2n plus 2. This is the general formula of alkane. So if you put what is N here? Number of carbon atoms. I hope you discuss all this with me, right? N means carbon atom. This is the general formula of alkane. So N is number of carbon atoms. Then when you put N equals 6, then HB equal 2N plus 2 means 14. That is called hexane. So number 2 will be cyclohexane, and the first one will be hexane. Right. So mostly, but here we are interested about benzene, real benzene, not hexane or cyclohexane. But when Kekulé structure undergo hydrogenation, you get cyclohexane. Then now you can write the energy will be what? Now one hydrogen, addition of one hydrogen is minus 20. Now it is what? Minus 20 into 3. Can you understand that? Addition of 3 hydrogen is minus 20 into 3. Then what is the total? It should be minus 360. What is the total energy release? Minus 360 kilojoules for all 3 hydrogen. But actually real benzene is different. So it's minus 208. What is the hydrogenation enthalpy of real benzene? Look at here, minus 28. That means minus 208 and minus 360. Magnitude, if you take, which one is larger? Magnitude. Who release more energy? Kekulé structure. Kekulé structure has lost, given out minus 360. That means minus means exothermic. And real benzene only minus 208. So this is also the second evidence that real benzene does not contain 3 separate 5 bonds. So it's a ring resonance hybrid or 5 electron cloud. The unhybridized p orbital has laterally overlap and form a ring structure. That means who has more energy? To release to release 360 joules, Kekulé structure has more energy. But the real benzene release less energy because it releases only 208 kilojoules heat, less energy. So one who has less energy or one who has more energy is more stable. Tell me. Now calculate structure of the resonance hybrid having low energy, resonance hybrid or the real benzene. Therefore, the one with lower energy stabilizes. I mean more stable, more stable. You can see that is what shown in the graph. So this is like you had unknown energetics, energy profile, energy level diagram or enthalpy level diagram. So this calculate structure when you do the hydration minus 360. Look at your tute if you have got a printout of this. So therefore what? This one has how many energy? Extra energy. Calculate structure has, I'll highlight this, 152 kilojoules extra energy. So how to get this? Minus 360. If you subtract 208 from 360, if you subtract, how to get my 152? 360 kilojoules minus, now think about only the numerical, I mean the magnitude. 360 minus 208. What is the gap? 152. If you subtract this, you will get 152. That means Kekulé structure has 152 kilojoules energy than the real benzene. Therefore, Kekulé structure unstable. Therefore, it's get stabilized. Therefore, out of these two, which one could higher probability to exist? The real benzene or the resonance hybrid. Therefore, Kekulé structure was rejected and the real benzene was used for the benzene. That's all the structure of benzene. What are the two evidences not to accept, or what are the two evidences for not accepting the Kekulé structure? One is Kekulé structure does not answer the test for unsaturation. Please copy down this below this one itself, below this paper itself, or else separately in your writing book, right? Kekulé structure does not answer the test for unsaturation. Therefore, the 3 5 bonds could not exist, since it does not answer the unsaturation. What is unsaturation means? What unsaturation means, if a compound has a double bond between carbon atoms, that is called unsaturated organic compound. If there's a 5 bond between any 2 carbon atoms of the chain, then it is unsaturated. Then it should answer bromination. That means bromine should be added into that, but that won't work in the Kekulé structure. So what you are right now, Kekulé structure does not answer bromination, or or else you can write test for unsaturation. Therefore 3 5 bonds could not exist as proposed by Kekulé. Then the second evidence for rejecting this hydrogenation enthalpy. Hydrogenation enthalpy of benzene is 208, but if you take the hydrogenation theoretically, if you check Kekulé structure, you should get 360, but you didn't get 360, you get only 208 kilojoules given out exothermic. So therefore real benzene or resonance hybrid is energetically by 152 kilojoules, it is energetically more stable. Real benzene, you can see its gap is 152. Benzene has low energy, Kekulé structure has higher energy. In order to release more energy during hydrogenation, it should have high energy, the structure, right? Okay, any questions you can ask. You can unmute your mic and ask, or you can put to the chat group. If you want me to explain, please tell. Are you okay now? I hope you understood both this, right? I mean the two evidences to reject the Kekulé structure, and why do we use the ring is the resonance hybrid. Instead of even oxygen O3, you had done the resonance hybrid, something like that. Can you remember the O3? O3, you can draw two resonance structures. Can you remember the same thing we have do here? O3, ozone. So that's one bond, and this is the other bond. So this is one resonance structure for ozone. What is the other resonance structure for ozone? You can shift the double bond to the other side. Right? You can shift the double bond to the other side. Here plus, here minus, and then here. So, but actually what happens, so this one can be shifted to here and this one can be shifted to here, then this 5 bond won't exist. So it's like a transition between these two. Therefore the resonance hybrid will be what? You put ozone like this. Same thing we do here. Then ozone, we do the resonance hybrid like this. Like we put a dotted line like this. You have learned this, right? So the same thing we do for benzene also. Benzene also, I'll erase this part. Okay, I'll use the whiteboard. This is a theory part, but you can get a statement question, so A, B, C, D type question from this. That's why it's bit important. They will ask you to explain this in detail, right? You can see the screen. I'll erase this part. When now you start in schools, your school also the teachers are on strike. Oh, or you have vacation, right? Okay, on 6th. When once the school start, can we do the class in the morning this time permanently? Or what do you think? Your school session start on what time? 6 o'clock, then we can't do now. Right, now look at this. I'll draw this parallel to this. Now the benzene one, this leftmost side, you can see the screen, right? Benzene one. Then I'll do this side, the Kekulé structure, proposed structure. Kekulé structure. Now this is C6H6, so this is O3, ozone. So here C6H6 benzene. Now this is, say, one structure, and then the other one is this. Then I can do like this. This bond is shifted here, and this bond is shifted here, like this. Then I can shift the bond to here, here, and here. So this also, this is called resonance. What are these two called? Resonance structures. So these are Kekulé structures. Resonance, they are resonance structures. So this is also Kekulé. This is also Kekulé. So these two are also called actually resonance structures for benzene. You can copy down this if you want. So therefore, the real benzene is not either one of these. The real benzene will be resonance hybrid of these two. Like in the ozone, now you can draw the resonance hybrid for this. It's like this. We put a dotted line like this. Like this. So this is dotted line means normally when you draw this, so in organic conversions we put a ring inside. That is the real benzene. So what is this called? Resonance hybrid. Resonance hybrid of benzene. Resonance hybrid of benzene. Please copy down this in your writing book. If ozone you have learned, so these are the resonance structures for ozone. Resonance structures, and this will be a what is resonance hybrid. Resonance hybrid of benzene. Resonance hybrid. Okay. Please copy down those who are still writing. Please raise the hand, those who are still writing. Okay, right, okay, you can copy down. When you are done, lower your hand, then I know go to the next one. Right. Okay. Ozone and benzene. benzene. Now the recording, even if you are join the class, if you want, now sometimes what happen, now you learn this, so after about 6-7 months you can't remember, right? Why did this happen? Why resonance hybrid is more accepted than the Kekulé structure? So I told two evidences. What one is the energy. Kekulé structure has more energy, resonance hybrid has lower energy. Experimentally they have proved that. And so how to convert resonance? If you want, you can convert resonance hybrid into Kekulé structure. Could tell me how to convert this? If you want, you can convert that. Experimentally you can do it, right? Experimentally you can do it. You can convert this real benzene into Kekulé structure if you want. Real benzene can be converted into Kekulé structure. How? How? Any of others? Yes. Tamasha, you have put to the chat, the school starting at 8:30 and you can do the class at 6 o'clock. Then until now, still we are not going to the office. So once the school, when the government, until the government schools open and the functioning, then until that, then I don't need to go to visit the schools for the inspection. So then until that I can do, until the schools, government schools reopen physically, we can do Wednesday 6. But anyway, I think your other classes also the schedule will change now with time when the schools reopen. So until that we can do then Wednesday 6 a.m. No? What about the others? You all are okay? So it's the school start at 8:30. Then I'll do from 6 to 8:30. Right. Every day, because I think in the morning time is I feel much like comfortable because you are fresh, ne? Otherwise after doing all the other classes you are coming Saturday Tuesday night to the class, I think you are exhausted. Okay, right. Ishara and Pramodi also okay, and then Tamasha also okay. Vinhara, you are okay, right? This time from until this, yeah. Okay, right. Okay, then we'll do like that. Then the class from next week every day, Wednesday morning 6 a.m. because then everyone can join on time also. Until I go to the office, so I can do that. But even that also, I can make it bit early, 5:30. When I'll check, let you know about that. Until our the work physical start, I can do this time because I'm at home. Work from home, right? Therefore, no problem. The problem is Tuesday morning. The actually with this, I told the syllabus change. For that, we have to write the modules now. Now we are writing the modules. A level not started yet, but grade 6 to 11. The chemistry part, I'm in the panel. So then the Tuesdays and Thursdays mostly they have the 9:30 the module preparation workshops by the NI, organized by the NI. Then university lecturers and everyone come for this. So that is compulsory. I have to online meet it. That's why the Tuesday morning the time problem, right? But Wednesday now anyway is 6 o'clock. Then it's no problem. Wednesday morning, right? Okay, done. We are done, right? So then I'll erase this. Any questions before I move to this one? Do you have any question? Now what you should write? Now I ask a question now. If you want, who has this Kekulé structure at all? This is 316 hydrogenation energy. So this one 208, no? The hydrogenation. How can you convert resonance hybrid into Kekulé? Kekulé is unstable because it has more energy. So in the real world, the resonance hybrid exists, like in the benzene. Like in ozone. Like ozone, there's no individual pi bond. How to convert this? You have to supply energy, or you have to reduce energy of the real benzene or the resonance hybrid. You have to supply how many kilojoules? 208 kilojoules. You have to supply. If you supply to the real benzene, if you increase the energy of the real benzene, it becomes Kekulé structure. Understood? Right. But it is unstable. If I will show the graph here, then you will understand that again. In the graph, you can see here. Can you see this graph? Everyone can see the screen, right? So if you supply energy from here to here, sorry, not 208, no, this is 152, sorry, not 208, 152. This one has 208, so this is, you have to supply 152 kilojoules, sorry about that, 152 kilojoules. Then it become Kekulé structure, right? So what is this one? This is cyclohexane, this last one, cyclohexane, C6H12, C6H12, right? Hexane is C6H14. Okay, they will never ask you to draw this graph, but they can give this graph and they can ask the reason, right? So that is called resonance stabilization. What is this process called? Resonance stabilization. That's why we call it resonance stabilization. That means resonance. That's why we are used to say resonance structures are more stable. When there are more resonance structures for a given, if you want to write this statement in your short notebook, when whether it's organic molecule or inorganic molecule, when there are more resonance structures, that molecule gets stabilized. When there are more resonance structures, that gets more stabilized. We call it resonance stabilization. Even sometimes intermediates, like in organic reactions, when intermediates undergo resonance structures, when the intermediate has resonance structures, what happens? That path is more predominant, I mean more likely to happen. The reaction could occur through that mechanism, through the path which contain more resonance structures for the intermediate. Those things are very, very important. Now remember, under I think will be a like education system also, by 2025 there will be a big change. Now I think digital platform becoming more popular. Remember, I'll tell you one example for this. Now you have done organic practicals or inorganic or organic practical in school. What happened? Now you take a chemical you have to prepare, and you can add here potassium permanganate or something. You add K2Cr2O7, and then you put here say aldehyde, and what happened after the reaction? You go to and dump this all the remaining stuff into the sink. From the sink it goes to the environment, whatever the reagent that we use. So at the end of the practical, you are dumped into the sink in your the laboratory in school, A-level chemistry lab. So from the sink it goes to the environment. What happens is chromium, zinc compounds. So most of the D block contain transition metals. They are heavy metals. Chromium, manganese, copper, all these are heavy metals. So those heavy metals are released from your school lab. Have you ever asked from your school teacher to where it is going? From the school, that zinc, I don't think they should store that in a separate barrel, and that organic compounds, you have to store the organic waste in the lab separately in a barrel and inorganic waste separately. But actually you have to wash it, you have to clean the place, right? Have you done in school the chemistry, any practicals in school after starting your A level? Have you all done in the school chemistry lab any practicals? At least simple titrations. Probably this time batch, okay, you have done, right? Few practice. Okay, if you have done, then you know this. So you have to clean the place. You have to wash all the test tubes and everything. You have to clean the place. So otherwise you get nicely scolded from the teacher. So what happened? You are cleaning means you don't put that into a separate barrel. You just dump to the sink and then you wash it. Right? You clean the glasswares. So what happened? From all the Sri Lankan schools. So if it is deposited, what happened? Nearby, what happened if there are wells, the water inland, water bodies? So they get polluted. Right? Now you learn in environmental chemistry or A level, the last chapter lesson, environmental chemistry, but environmental pollution. But the school, you don't practice that in school, right? The good practice. So therefore, laboratory practices. Now we pollute and we come and get learn it. That is the most important. So therefore, next day ask from your one day when you start your school physical class, ask from the teacher to where this is going from our sink in the school. So they might tell you there's an underground pit. So then from underground pit it can get soaked to the soil. Then they actually, most of the school, they have a concrete like cement, sealed one tank. Then water gets evaporated and chemical deposits, so it will not leak to the soil. But most of the school, they don't have that. Some of the school, they are directly released into the environment, right? Underground pit. But that is really bad. if you are growing any crops in that environment, or if there are any wells in that in your school, so those people will drink that water contaminated with heavy metals. If you are like, but in that's why you have to use the smallest amount possible in the school laboratory for the practicals. Sometimes what happens for fun, you feel I'll put little bit more to see the color change occurs further. So don't do that. So not wasting chemicals, you are wasting the environment, polluting the environment and burning more money, but you get the same effect. So because you are not going to manufacture any products to supply the demand of the customers, you are just to learn chemistry. So therefore you have to use that is called now there's a concept called green chemistry. If you want to consider green chemistry, under green chemistry principles we use minute amount. Now what I am trying to do is this digitalization. What happens now, the chemistry also become virtual lab. You will get virtual reality, augmented reality. I don't know if they have heard of this word, augmented reality, AR. Have you heard of this AR, augmented reality? What is called the other one is called AI, artificial intelligence, and augmented reality. With this you get virtual lab, right? Now in virtual lab, what happened? Has anyone of your teaching school has used the virtual lab for your practicals? No, right? No. Okay. If I don't know whether you have downloaded. So there are now upcoming ones. So I'll try to do one day in the future. So then you have what happened? All the test tubes. You have the test tubes in the virtual lab, and you have the chemical reagent bottles. So what you do now? You have, imagine you have 2 chemical reagent bottles. It's a virtual lab, right? Now you have one. You have potassium dichromate, K2Cr2O7, and the other one you have aldehyde, CH3CHO. So then you can handle and everything there. Then you can transfer this to the test tube. From this you can transfer, from this you can transfer. Then test tube will give the color change. So this is the color change. The real color what you observe physically in the lab will be displayed here. Then you learn it. No, you do the same thing. Only thing is like, you know, your skills problem. The skills means you don't touch the test tube, but you can. That also has happened in India. This is very popular. Now in our country it has not come yet, but the other countries, they teach all the practical. They are doing practical. If you ask from the school, are you doing chemistry practical? Yes, in a virtual lab, right? Now with the hologram technology, this will become real, like tangible one also in the future. That will happen. Like you get 3D cinema like that. So something like that you will get all this in front of you in your class. Sorry, at home. Right? So that is. So I don't have time to explain all this, but anyway, in the future there will be a lot of changes. Therefore, when you pass out from A level, when you pass out from the school, and when you start working, the world, it's new world, right? So now also they are talking about new normality, no? Not normality. You can't come back to the new normal situation, right? After COVID. So that new normal situation is this digitalization. Digital currency, no physical currency like that. Okay, and then let's move on to now. That is that's all about this. Now this one I explained last week. This 5 electron cloud chemistry. I told you this what each carbon. I told the previous lesson, sp2 hybridize each carbon. I asked this Mentimeter question also. What is the hybridization of carbon of the benzene ring? Now this unhybridized p orbital laterally overlap. That's how you get this ring. That is the meaning of this ring. This this is called 5 electron cloud. 5 electrons laterally overlap, laterally or unhybridized p orbital, and these 3 will be 360 degrees. This is sp2 hybridized orbital, this is sp2 hybridized orbital, this is also sp hybridized orbital. sp2 hybridized orbital, this one, to form this sigma bond, this linear head-to-head overlapping, like this. Do you understand? If they ask in the exam, you should know this, right? CH bond is formed how CH bond is formed? You get like this, no? CH. So this CH bond is formed how? Linear overlapping of 1s orbital of hydrogen with sp2 hybridized orbital of this carbon. Then how this sigma bond is formed? That is how CH sigma bond is formed. The CH sigma bond is formed by the Can you write it here itself? Did I tell this previous class how this bond is formed? Sigma bond. Sigma bond. Due to the linear overlapping of 1s orbital of hydrogen and sp2 hybridized orbital of benzene, the carbon atom. Please, if you want, can mark that here. And this side the bond is formed, the CC bond is formed. I'll draw for only for one, then the others also same. This sigma bond is formed by the linear overlapping of sp2 hybridized orbital of one carbon with the sp2 hybridized orbital of adjoining carbon. Is that clear? So this is sp2, the pink one also sp2, that is sp2 head to head overlapping. That is how this sigma bond is formed, this sigma bond, right? CC sigma bond. And this is the sigma bond also what? sp2 linear overlapping. Each sigma bond between carbon atom of the benzene ring, linear overlapping of sp2 hybridized orbital. That's how sigma bond is formed. CC sigma bond between carbon atom. CC sigma bond is formed how? Linear overlapping of sp2 hybrid orbital of one carbon with adjoining carbon, with nearest carbon. Adjoining carbon atom. Then the other one, right, next point, CH sigma bond. CH sigma bond is formed how? Linear overlapping of sp2 hybrid orbital with 1s orbital of hydrogen. sp2 of carbon, right? sp2 hybrid orbital of carbon with 1s atomic orbital of hydrogen. sp2 hybrid orbital of carbon with 1s orbital of hydrogen. That is how CH bond is formed. Then you get the 5 electron cloud. Those are what are the three types of bonds in the benzene ring? You get CH sigma bond, CC sigma bond, and the 5 electron cloud. That's it. Entire benzene ring. That's it. This dotted line represent here this one, lateral overlapping of unhybrid p orbital. You can write that 5 electron cloud. The third, if you want, you can write the third point, CC sigma bond, CH sigma bond. Then the other one is 5 electron cloud. 5 electron cloud. How it is formed? Lateral overlapping of all the sp2 unhybrid p orbital. Lateral overlapping of all the sp not all, or not sp, unhybrid p, all the unhybrid p orbital, unhybrid p orbitals, unhybrid p orbital, unhybrid p orbitals, unhybrid p orbitals, p orbitals. Understood? 5 electron cloud, lateral overlapping of all the unhybrid p orbitals, CH sigma bond by the sp2 and 1s, and the carbon sigma bond, linear overlapping of sp2 hybrid orbitals. So they can ask this in the exam. They can give a statement what? Which of the following is incorrect about the structure of benzene? There are past paper questions. I'll discuss this upcoming classes. Right. Anyone still copying down this? If you want me to explain, please raise the hand. I can explain again. If you need any clarification, please don't hesitate to ask. Right. Because you can't. Anyone done this before? Right? Not yet, right? Anyone done the benzene, the structure in theory class? Then tell me, because then I don't need to waste much time and I can directly go to the questions. Now September, today is 1st of September. Now you have completed 1 year now, right? 1 year now. You are supposed to complete organic. Now you should be in chapter 10. But still I am trying to recover this, because I can't wait until you complete everything the theory class. Then after the A level class, A level after your exam only, I have to do the revision of the last few lessons. So that problem will arise in the future, not now. Because physical chemistry is more hard than. Then what I am planning now, I will do 1 hour theory explanation, and then we'll go to the questions of that section, past papers, and we'll do the revision. Yeah, that's what we are doing now. I'll do for that for the upcoming lessons also. It won't take much time to explain theory, but you have the resource book. No need to copy down a note. Try to understand the concept and put a short note. That's enough. Then you can do the questions with me. Shall I erase this? Anyone still copying down? Please raise the hand. Okay, right, done, right? Okay. So any questions to ask about this? The structure of benzene. Any questions? Can you see here the hybridization? So this is how the sigma bond is formed. So this is CC sigma bond. You can mark that here also. And this one sp2. This is sp2 with 1s. That's how you get CH sigma bond. Here also, if you want, you can mark with the red pen. 1s orbital. No need to mark all. So at least for one carbon you can mark like this. That's how you get the sigma bond. Then you get CH sigma bond. So what is this? You can label this one as, this is how linear overlapping of CH sigma bond is formed. And this one you can write, you can select like this one, sp2 hybrid orbital of one carbon and sp2 hybridize of the other one. You get this will result CC sigma bond, carbon sigma bond in the benzene ring. Benzene is cancerous, right? Benzene is cancerous. C6H is cancer causing agent. Naphthalene has 2 benzene ring. If you can search in the internet, this is naphthalene. So that is naphthalene means kapuru. Like what is this called? You get the smell. Mothballs, I think it's mothball, no? Yeah. That is not good to inhale. Sometimes you can see the public toilets and these white colored balls, even the hotels they put in the washroom to get rid of the bad odor. But now it's not used. People, they lack of this knowledge. I think that's not good to inhale. And this one, what is the other bond? This 5 electron. So it's a 5 electron cloud, not shown here, right? Please mark this in right. See how the bond is formed. What is the bond angle? So those things you know, right? 120 degrees Celsius. This is the top view. Actually, this is the top view. Top view. This is the top view. So this is also the top view. The same thing in a different form. Right. So this top view. And this is the side view. This is the side view. Side view. Side view. Now here the first two diagrams, the top view, this is side view, and the first two diagrams, earlier one, the one we discussed, that is CC sigma 1 and CH sigma 1. This is to indicate how unhybrid p orbital. If you want to label this one as what? Unhybridized or unhybrid p orbital. Each carbon has unhybrid p orbital. So this is what laterally overlap, right? That's why because according to Kekule's structure, what? According to the Kekule's structure proposed by the Kekule, the scientist, so then it's like here the overlapping, only here the overlapping, and here overlapping, like that. So but practically it's they have not observed this. Only these between these two, the overlapping. 5 bond is formed. Only these 3 5 bonds. But actually what happened? They all laterally overlap. All these laterally overlap. Understood? That is why you get the ring here. Not this. But this is also possible. If you supply energy to the real benzene, you get the Kekule. How many kilojoules? 152 kilojoules. So did you write here the real benzene or the hybrid resonance is what? It is more Like energetically it is more favorable by 152 kilojoules than the real the calculate structure. The real benzene is more stable by how many kilojoules? By 152 kilojoules than the resonance, than the calculate. So I think if you can remember these two pages, this diagram, if you can explain, that's it. No need to monitor separate thing. So the say if you want to, now you can read and understand everything given in the resource book. Now after my explanation every class, you just, because no point of wasting time again for this resource book, because you already have ne? So no need to come. Most of the teachers, they look at the resource book and again give in a note, but that's my thing. It's no point. Resource book will be your note. That is more than enough. Actually, previous A-level paper, there was a problem in the question. They had to give free mark because the resource book they have given, it's in the incorrect format. That is about water, that amphoteric nature, that question. Okay. Then this is about real benzene. Now let's move on. Okay, this is the resource book. So please read this, right? Please write in your that this paper, that aromatic organic compound, the 2 pages one. Near this, write everyone. Refer page number. Then later when you study, then you will, if you need further clarification, you can refer the resource book, right? Resource book page number. Organic chemistry resource book page number 44, 44, 43, 44, 42. Page number 42 onwards. 42. Not 42. 41. 41 to 41 to 44. 41 to 44. Right. So they have got 4 pages. 4 pages. Right. So characteristic reactions of amplifying the stability. Right. Can you see here the why benzene shows extra stability? So you can see in the resource book they have one why this benzene is extra stability than in the alkene. Alkene also has 5 bonds. This for delocalize. What is this called? Delocalization of electrons. That means 5 electrons get delocalized. That's why you get the resonance. Therefore, benzene does not easily undergo with destroying the cyclic delocalization. That means that ring structure will not break. That's what they are telling here. It's very difficult to break this ring structure because 5 electron cloud laterally overlap all the unhybrid p orbital. So that's why it gains extra stability, delocalization of electrons. That is why we call it resonance, stabilization. Therefore, you cannot add BRT to benzene. You cannot add BR to benzene. Will not answer for the test for the unsaturation. Right. Here, this also you can highlight if you want. If you have the resource book, the page number 44, page number 44. This is also a bit important. These are the areas where they can raise questions. Can you see here? This is what I explained you. Hydrogenation of 3 triple bonds. So 360. Then Kekulé structure more stable than Kekulé structure by how many? By 152 kilojoules. Can you see here? Benzene is more stable than Kekulé structure by how many kilojoules? By an amount of 150 kilojoules. That is due to what? Why this stabilization, extra stabilization? Due to the cyclic delocalization of 6,5 electron. Please highlight here. Please raise the hand those who have got the resource book. I mean the hard copy. Page number 44, organic resource book, page number 44, hard copy. Only Tamasha Nishad, right. Others, please write in your writing book, no need to worry, right? Resource book, page number 44, right? This is important. You can copy down at least this sentence that these are the areas where they can raise questions. So, and it is termed as what? Resonance stabilization. This is what I explained. This is called resonance stabilization. This is what I explained in my theory too. I mean that theory, I mean summary. What is this called? Cyclic delocalization of 5 electrons known as what? Resonance stabilization. The stability is due to cyclic delocalization of 5 electrons. What is this called? Resonance stabilization, or we call it aromatic stabilization of benzene. Aromatic stabilization of benzene. Right. They can ask either A, B, C, D type questions or statement questions from this part. There are possible questions from this. That's why I explained this. Okay. Now let's move on to the next part. Shall I erase this now? Okay. Right. That's all about benzene thing. Then we have to do the reactions of benzene. Right? Okay. Now chemical reactions of benzene. Now can you write it down? I'll use the PowerPoint. After that I'll cover the 20 paper questions. I'll use the Zoom whiteboard. Right. Can you see the screen? Okay. So what is the summary? Please write in your short notebook summary of what? Chemical reactions of benzene. Chemical reactions of benzene. Now I will give you one example. Now this fast revision, I'll give one example. If you want, I'll share this with your group. 2020, you can see the performance of candidates. Now usually the all like medicine, what happened, nearly 60 to 70% enter in the medical faculty from the second try and the third try. The first try it's less than 40%, right? That means what happened, the first time when you are doing the first try your A level local, what happened, you don't have much experience about the revision. I mean less time to do the revision. That's some of the main problem. So to complete the theory syllabus, I mean the syllabus itself, it takes a lot of time and teachers find it difficult to do much revision. So second time when you are doing sometime after this one, they do maximum revision, pass papers and get prepared. So that's the problem. If you can do both within the first year, I mean first 2 years, when you're doing the first try, then you can face this challenge well. Otherwise that will be what engineering is a different scenario. So engineering, mostly people they are studying in the first try also. Then biology this problem, because biology syllabus, huge syllabus, memorizing part is more, so it takes more time for the students, some of the students, right? So that's why I told now this revision thing also you have to do, because remember there's a group of students keeping 3 A's in their hand, repeating the A level, right, with you. You don't forget it. There are students with 2 A's and 1 B in their hand. They are repeating. Why? They have not got the enough study score. So these 3 A's can be 76, 77, 78 like that. So then the people, those who get A with 90s marks, 80s, then they get from the first try. Understood? Therefore, you have the competition with them also. Don't forget it. You are sitting your exam with set of people, those who have got 3 A's from the first try. But you don't have any idea about that. You have not faced any exams or the standard national exam. That's why it's important. Not only your batch, there are 2 batches repeating previous. Now summary of chemical reactions of benzene. I'll put a chart here. Please write. Okay, you put the benzene in the middle. Okay, put the benzene in the middle. Right. Please copy down this summary in your writing book. I'll put the main reactions first, and then any side reactions I'll put separately. Right, please copy down summary of the chemical reactions of benzene. So first one, we call it, there's a name also, but in the exam don't ever write the name, right? Don't ever write the name. First I'll write formation of methylbenzene, or we call it somewhere toluene. Here CH3 group. What is this called? We call this, what is the name given to this number one? Alkylation. What is this number one called? Alkylation. The first reaction, alkylation. To do this, you plan to put anhydrous AlCl3 plus CH3Cl. Mechanism of selected reactions I will do later. This is the first reaction. And I put anhydrous, An dot, ANHY, I put anhydrous. Anhydrous aluminum chloride, because in the aqueous medium aluminum chloride is unstable. Anhydrous AlCl3, AlCl3. Anhydrous AlCl3. Then next one. Second one, right? That is anhydrous AlCl3, CH3Cl. Next, right, nitration. Nitration means we call it nitrobenzene. Nitrobenzene. You can see the screen, right? Nitrobenzene. What is NO2? Nitrobenzene. We call it nitration. I put reaction number 2. Reaction number 2 is reaction number 1. Reaction number 2, nitration. How to do this? You can put ConHNO3 and ConH2SO4. ConH2SO4. If any of these unplaced, please ask. What is this called? Number 2 called nitration. Nitration. Number 1 called alkylation. Alkylation. So this is called nitrobenzene. What is the name given to this? Nitrobenzene. So this is called methylbenzene or toluene. Methylbenzene or toluene. Methylbenzene or toluene. Next one. If you want, you can write the name. This is called methylbenzene. I'll use a different color, okay, blue. Methylbenzene. Within bracket, right? Toluene. And this one, nitrobenzene. Within brackets, right? This is nitrobenzene. This reaction is called nitration. Reaction number 1 is alkylation. Reaction number 2 is nitration. I'll write it within bracket if you want, nitration. Reaction number 1 called alkylation. 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 Clear? Done? Then third reaction, right? Chlorination. Chlorination. Addition of chlorine. So nitration, alkylation. Sometimes we call it Friedel-Crafts alkylation. That's the name, but don't write the name in the exam. There are no marks. Without writing, if you write just the name of the reaction, we call it Friedel-Crafts, Friedel, Friedel-Crafts. Can write here Friedel-Crafts. That is the name of the scientist who found this. Friedel, Friedel-Crafts, CRAFT. Friedel-Crafts alkylation. Friedel-Crafts alkylation. Friedel, CRAFTS. Right. Then third reaction, right? Next reaction, right? We'll do halogenation. That means addition of chlorine, bromine, iodine. Halogenation. 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 please write this one, halogenation. Number 3, reaction number 3, I'll write halogenation. For halogenation, what are the reagents? Again, anhydrous AlCl3, anhydrous AlCl3 and chlorine Cl2, anhydrous AlCl3 and chlorine. Then you get here chlorobenzene. What is called chlorobenzene? Chlorobenzene. Chlorobenzene. Right. Then next one. Chlorobenzene. Next one, right? Reaction number 4. Fourth one. What is that now? Friedel-Crafts alkylation, nitration, halogenation. Halogenation. Then next one, right? Acylation. What is called acylation? Number 4. What is halogenation? If it is addition of chlorine, we call it chlorination. Chlorination of benzene. Right? Chlorination of benzene. Or if you want, you can write here bromination, addition of Br. Okay, right. But remember, all like in the alkene, the 5 bond is not broken down when adding chlorine. Both the chlorine Cl2, it is not addition actually. I'll come to this. All this substitution reaction. Substitution reaction. Okay. Reaction number 4, fourth reaction, right? Friedel-Crafts acylation. Friedel, Friedel-Crafts, CRAFTS, acylation. Acylation, Friedel-Crafts acylation means you get here benzene ring, CO, you get a ketone here, COCH3, ketone group. So both the ends are around the carbonyl carbon, two alkyl, the benzene ring and the alkyl group. That is a ketone, aromatic ketone. Aliphatic also they are, aromatic they are all. Ketone. Aldehyde also you can have aliphatic and aromatic aldehyde. Do you get it now? Ketone, if you this is aliphatic. This is propanone, acetone. Acetone is aliphatic ketone. This is aliphatic. Aliphatic. This is aromatic. Aromatic. Most of the things that you come across in your day-to-day life, pharmaceuticals and polymers, and then all these cosmetics, so medicine, all these aromatic ones actually. Aromatic. Aliphatic ones, most of the time you are using fuels, right? Fuels. Then what are the reagents for this? Right here again, anhydrous AlCl3, anhydrous AlCl3 and CH3COCl, anhydrous AlCl3 and CH3COCl, anhydrous AlCl3, CH3COCl, COCl, right. Actually remember, I will write here within bracket active species in front of each. Active species in front of each, right? If you add in, then you have everything in one place. Otherwise you have to read the long paragraph in the textbook, the resource book. So this is the active species will be what? CH3 plus. That is the electrophile. So this is CH3 plus. This is the one who come and replace the hydrogen of the benzene ring. Here what happened? What is the active species? NO2 plus. Here what is the active species? NO2 plus. NO2 plus. And here the active species will be Cl plus. Cl plus. In the under chlorination, who come and attack the benzene ring? Chlorine, Cl plus. In nitration, who come and attack the benzene ring? NO2 plus. In alkylation, Friedel-Crafts alkylation, who come and attack the benzene ring? CH3 plus. That means all these are called what? Positively charged ions are called electrophiles. Electrophiles. Here who come and attack the benzene ring here? CH3CO plus. That means what? Chlorine go out. So this is CH3CO plus. So that is called, that is the electrophile. So that is the electrophile. Electrophile. Can you write here? All these are electrophiles. Right. I will don't label all this. So this is electrophile, or we call it sometimes in the paper they give you active species. Or you can write within bracket electrophile. Electrophile means the ion which is positively charged. Electrophile will that is an ion which is positively charged. Positively charged ion is known as electrophile. So there are NO2 plus will be the electrophile in the actually what is present in, if you normally we don't write, okay, this benzene, don't forget each carbon has hydrogen. So this hydrogen is replaced by what? This electrophile. Electrophile come and replace, if you only can write using your own words, electrophiles come and replace hydrogen of the benzene ring. Come and you can write, then you will remember. Now I'll give that using your own words. Electrophiles come and replace. Replacement means substitution. It is substituted by, it is, that place is taken by the electrophile. Electrophiles come and replace hydrogen atom of the benzene ring. Hydrogen of the benzene ring. Therefore, what is this? Therefore, the reaction type is known as what? Therefore, the name of the reaction, or the reaction name, or the mechanism name. Therefore, it is called electrophilic. This is very, very important, this word. Electrophilic, not addition, substitution reaction. What is this reaction called? Electrophilic substitution reaction. Very, very important. Any questions? Please highlight this. Electrophilic substitution, highlight. Why it is called substitution? Hydrogen is replaced by whom? This electrophile. Remember the other places also this hydrogen is available. All 6 carbon C6H6 ne? So normally we don't write it. Here also for your information I wrote it. Otherwise you don't know what is why it is called substitution. Right. So they come and replace this. We call it electrophilic substitution. I have 4 main reactions for this now. There are 2 more reactions. I will give this separately. There's an oxidation reaction. Wait, we'll do that separately. These are the substitution reactions. If you put H2SO4 also, sulfonation, that was there, but in the new syllabus it's not given in the resource book, I think. Right. And they have given hydrogenation. You can do cyclohexane also can be done. That is not the other reactions I'll give separately. Otherwise, it's become like very complex. There are 2 reactions. I'll give that separately because it's not under substitution. They are under different mechanisms. Done? Instead of anhydrous AlCl3, you can use here Fe for the bromination or chlorination. You can use FeBr3 also. Please remember that also. Can you write the other reagent for this chlorination other than AlCl3, Cl2? You can use FeBr3 and Br2. for the bromination FeBr3Br2 or FeCl3Cl2 anhydrous FeCl3Cl2. Can you please write that also, the other reagent, possible reagent for this? I'll write here how to write this somewhere here. You can write here anhydrous AlCl3Cl2, or you can write I'll put a slash and write here. We have to write, okay, I'll put here FeCl3Cl2 also can be used. FeCl3 comma Cl2, not slash. FeCl3Cl2 can be used instead of anhydrous CaCl3 and Cl2. There are two reagents that can be used for this. Anhydrous, that also should be anhydrous FeCl3Cl2 or anhydrous AlCl3. So electron deficient agent, this AlCl3 Cl2, it can capture chlorine. Done? Anyone is still copying down this? Please raise the hand. Or if you have any doubt, anything to clarify here, any of these reactions, you can ask. Any doubt? If you want me to explain, please ask. Right. Now right below this separately, there are two other reactions which they don't fall under this type. That is bromination also you can do, right? Bromination also you can do. Please write hydrogenation. That we did cyclohexane, something. We can add hydrogen into benzene ring. We call it hydrogenation. For that we can use a catalyst, catalytic hydrogenation. What is called? Catalytic hydrogenation. Addition of hydrogen to benzene. Addition of hydrogen. Then you get C6H6 oxidation, Raney nickel catalyst, nickel catalyst, and add in hydrogen. Shall I erase this? Okay. Higher temperature. Okay, I'll move to the next one. Please write these two reactions separately. Number one, write hydrogenation of benzene. So all these for the previous four reactions in the flow diagram, electrophilic substitution. Electrophilic means positively charged ion. Positively charged ions love to take electrons. So they like to get electrons. They are getting attracted towards the electron. That's why I call it electrophilic, like hydrophilic gets attracted towards the water. Like that. So the one positively charged ions get attracted towards the electron rich places. Positively charged ions or electrophiles get attracted towards the electron rich place. What is the electron rich place? Benzene ring, 5 electron cloud. In the benzene ring, 5 electron cloud is rich in yeah. So that is what is hydrogenation of hydrogenation. So you can write within bracket addition reaction. It is an addition reaction, not substitution. Nothing is replaced. Just hydrogen gets added to the benzene. Just hydrogen gets added to the benzene. So this is how it happens. You have the benzene ring. Then you put here nickel catalyst with hydrogen, and to about 150 degrees Celsius at high temperature, it is undergo, we call it catalytic hydrogenation. Actually this is catalytic hydrogenation. In the exam if you write hydrogenation enough, but in the process of catalyst, then you get what? Just benzene. So if you want to write the formula, this is C6H6, it is benzene become C6H12. C6H12. That means it's like this. It's not necessary to write this, but just to understand I'll write here, H2 get added. HH. 1H is already there. 1H is already there. So here C6H12. But in the exam, it is, if you write like this, that also normally this terminal hydrogen we don't indicate here. Normally it's hydrogen, 6 hydrogen there, but normally we don't write it. But for the first time when you write it, then you must be wondering where hydrogen was added, then it is not shown here. So because of that doubt, I put here all the hydrogen around the carbon atom. So what is the formula now? C6H12, no? C6H12, what is this called? Cyclohexane. Cyclohexane. That is, and the other one, right? There's one more reaction, oxidation. Actually, only benzene cannot undergo oxidation. Benzene, if you want, you can write bromination also here. That's same as FeBr3Br2. Then oxidation reaction. So only benzene cannot undergo oxidation, but if there's a monosubstituted, that means benzene is resistant for the oxidation, right? Please write below oxidation, right? Only benzene cannot undergo oxidation. Right? Only benzene does not undergo oxidation, but with the oxidizing agent, even with a strong oxidizing agent, that won't happen. But methyl benzene, earlier you got alkylation. Look at the first reaction, you got alkyl methyl benzene, toluene, that is called toluene. So if there's an alkyl group attached to the benzene ring, at least with one hydrogen, I'll move to the next one for this second point, right? Under oxidation, right? Under oxidation. Under oxidation, benzene, I'll do like this. Only benzene, if you put acidified KMnO4, no reaction. So it is resistant for the oxidation, no reaction. But earlier in the first reaction, you got methyl benzene. Methyl benzene can undergo oxidation. Then if you put acidified KMnO4, it becomes benzoic acid. What is this called? Benzoic acid. It's a carboxylic acid. So that is a type of carboxylic acid. Benzoic acid, it's a carboxylic acid. Aromatic, no? Aliphatic. If you take acetic acid, that is aliphatic. This is aromatic. Then both are carboxylic acids. Do you understand? If you write here CH3COOH, that is called acetic acid, ethanoic acid. That is aliphatic. This is aromatic. That is the difference. So this one is heavier, benzoic acid. It's a white precipitate. It is not soluble in water. Benzoic vinegar soluble in water, CH3COOH, because carbon, even though now someday you might ask, COOH group is there, it can form hydrogen bond. Why benzoic acid is insoluble in water? You can ask that question. So if you ask that question, then I can tell what this one has a lot of carbon and hydrogen because it's heavier. C6H6 here itself more than 70, right? So if you take the relative molecular mass, therefore to oxygen it's a bit heavier than, so when the carbon number increase, so the solubility drop. Even if you take ethyl benzene like this, I put here CH2CH3, this also undergo what? Oxidation. It becomes COOH, benzoic acid. So that what is the main requirement? There must be hydrogen attached to there must be at least one hydrogen attached to the carbon of the benzene ring. I mean, carbon attached to the benzene ring should contain hydrogen for this. That means primary and secondary alkyl groups get oxidized. Tertiary alkyl groups won't get oxidized. So the next one, right? If you take this kind of situation, if you take even this one, if you take CH, CH3 CH3, then this also get oxidized. This is secondary alkyl halide. This also becomes COOH. What is the main requirement? There must be at least one hydrogen attached to the benzene ring. Not benzene ring, to the carbon of the benzene ring. The carbon directly attached to the benzene ring should contain at least one hydrogen. So here one hydrogen is there. I will highlight that hydrogen. Here there are 3 hydrogen, primary. So there are 3 hydrogen. Here there's 2 hydrogen. Here there's 1 hydrogen. Now what is the next one I can draw now? Next one I can draw, I'll draw the rightmost side. But no, only benzene cannot undergo sun. This also cannot. I'll draw with a different color. This one. If you take benzene ring with tertiary alkyl halide. So imagine that this carbon, there are 3 CH3 groups. If you want to get idea, what is this called? Tertiary alkyl halide attached to the benzene ring. Tertiary alkyl halide. To this one, if you put acidified KMnO4, to this one, if you put acidified KMnO4, it will not undergo oxidation. No reaction. So the first two, these two, no reaction, right? So these two, no reaction. They cannot be oxidized by even with acidified KMnO4. These two you can copy down separate. Okay. The others can. Other reactions will occur. Okay. Done. Anyone still copying down this? Right. Anyone still copying down this? Shall I erase this? Right. So what you are right now? Benzene can. What are the 3 types of reactions did you learn now? What are the 3 types of reactions you learn now? Number 1. What is the main characteristic reaction of benzene? You did in the flow diagram 4 reactions. I'll move back to that previous one. Here what is this? Please highlight electrophile CH3 plus Cl plus Br plus CH3CO plus. That will be the electrophile. So this is electrophilic substitution. Can you please write with the red pen for below this? Look at the board. Look at the screen. What is the main characteristic reaction? The main characteristic reaction of benzene. The main characteristic reaction of benzene is what? Electrophilic. Highlight the word electrophilic. Electrophilic substitution. Please write that with a red pen. Please write it. The main characteristic reaction of benzene is electrophilic substitution. What is substituted? Hydrogen is substituted by electrophile. What are electrophiles? Positively charged ions, the one who attract electrons. Electrophilic substitution. Right. Then next one. But benzene can undergo these two also. Next one I told, what is this? This one, hydrogenation. That is addition reaction. Addition reaction. But it's only with this, so not much addition reaction. If you put only bromine, this be careful. Benzene does not answer the test for unsaturation. Right? If you feel like someday in the exam, if they give this, then you don't know. If you put benzene Br2, no reaction, no reaction. But if you want to add bromine, what should be done? You have to put that as a FeBr3 as a catalyst. FeBr3 Br2. Now it works. Then you get bromination, bromobenzene. Then you get bromobenzene. This will work. But only bromine won't work like in alkene. Alkene, yes, only bromine enough. Non-polar medium. Br2 CCl4. Bromine get added. The electrophilic addition. Alkenes electrophilic addition. Alkanes free radical substitution. Benzene electrophilic substitution. These are the areas where they ask questions in the paper. I'll show you some of the questions after this now. Done. Then next one I explain what it is. What is that? Yeah, this one. This one I told that is oxidation. What is the next type of third type of reaction shown by the benzene? Oxidation reaction. Mechanisms I will do, all the important mechanisms I will do separately, right? So after the reactions of all the organic compounds. So under reaction you should know what? The name of the reaction or the type of reaction or the mechanism type, reagent and the main product. Reagent and the main product. Now what is the observation here? Purple color of KMnO4 get decolorized. So this can be used as a test also actually. Can you all please write here observation, right, in this reaction? Observation, purple color get decolorized because KMnO4, why is this called oxidation? MnO4 minus ion get reduced. When benzene get when the methyl group get oxidized, MnO4 minus become Mn2 plus. That means oxidation number has decreased from plus 7 to plus 2. Plus 7 to plus 2. So this is reduction. So what is the color of MnO4? Purple. Mn2 plus colorless in the acidic medium. Then what is the observation? Purple color get decolorized. Purple gets decolorized. Understood? Decolorize. Right. Okay. Any questions? That's all you have to remember about benzene reactions. Shall I erase this? Anyone still copying down? And right here benzoic acid. Benzoic acid is a precipitate. It is not soluble. It is aromatic because even is benzene water soluble? Benzene, will that get dissolved in water? Can it form hydrogen bonds with water? Benzene also insoluble in water. Benzene nonpolar, not soluble in water. Therefore methyl benzene will not dissolve. So even though COOH group is there, even though because this is the polar part, benzoic acid polar part COOH, then non-polar part is more dominant. Non-polar C6H6 part is more dominant than the COOH group. So it's like Ela haraka and Me haraka. So who is more stronger? Buffalo. So if you attach buffalo and cow, buffalo is more powerful than the cow. Then what happens, whether cow likes or not, has to go with the buffalo into water. So this is something like that. But they are the buffalo. It's getting attracted into water. So because hydrophilic part is more, buffalo is more. It's willing to stay in water, but cow willing to stay on the land. So that's what matters here. The significant, the magnitude of this electrophilic group and the electrophobic group. So some compounds having this diprotic nature, hydrophobic and but it's in Sinhala we call it uberprotic or something. In biology also you learn this no, I think diprotic or something. That means that substance of the compound having both polar group and non-polar group. Right? Polar group COOH, non-polar group benzene here. Therefore non-polar group wins from this. Non-polar group benzene ring wins from this. That's why it's water insoluble and precipitate. Right? Is that clear? Oxidation. And have you all heard about this food packaging and all this? It's used as a preservative. Most of the food label, I erase this, right? Anyone still copying on the previous one? Tell me. Then what is it called? So have you heard about this preservative? Sodium benzoate. Sodium benzoate. What is sodium benzoate? Sodium benzoate. Sodium benzoate is widely used in food, as a preservative. So this is benzoic acid. This is benzoic acid, CH3COOH. If you put sodium hydroxide into this, NaOH, it reacts with carboxylic acid, then you get this one, CH3COONA. So what is this called? Sodium benzoate. This is sodium benzoate. It is used as a preservative, sodium benzoate. Right. Sodium benzoate. So these are the reactions of benzene. If you want, you can prepare benzene also. There are some reactions to prepare benzene. This also I'll give you. Please go to the, shall I read this? Anyone still coming down? Right. Next one, right? Preparation of benzene. Preparation of benzene. How to prepare benzene from the other compounds. After this summary, I'll move to the questions. Preparation of benzene. I'll put the arrow now inwards. Put the arrow like this. Preparation of benzene. Look at the screen. You can prepare benzene from phenol. From phenol. From phenol you can prepare benzene. Then you get what is the reagent here? You can put zinc powder and you can distill it with zinc powder. Distillation. This is phenol. This is called phenol. But I'll write the name in front of this. This is called phenol. Phenol. It is insoluble in water like benzoic acid. Second one, you can prepare from carboxylic acid also. From benzoic acid you can convert back to benzene. Benzoic acid you can convert back to benzene. This is COOH, benzoic acid, COOH. So here you can put sodium hydroxide, NaOH, and calcium oxide, CaO. We call it soda lime. What is this called? Soda lime. You can heat this with soda lime. The name of this is called soda lime. Then it's become benzene. Fourth reaction to prepare benzene, we call it benzene diazonium chloride. We call it N2Cl. Here we call it N2Cl. N2Cl. What is this called? Benzene diazonium chloride. Benzene diazonium chloride. You can put H3PO2 and you can heat it. Then next one you can write with green art reagent. You can prepare benzene. MgCl. With green art to MgCl, if you put H plus H2O, then you can prepare that. H plus H2O. That means you put dilute acid. There's one more reaction. I'll write that this corner here. You can prepare benzene from this also. You can add C2H2. That is ethine or alkyne. You can pass through red hot copper tube. You can pass this through red hot copper tube. Copper tube, Cu copper. Red hot copper tube. Copper tube, like this. These are the methods of the preparation of benzene. These are the methods of the preparation of benzene. Right. So I told you now reactions of benzene and how to prepare them. Summary. Anyone still copying down this? So no balancing, no physical state. So it's easy. That's why organic chemistry is much easier. Don't always target your A-level paper. You get one essay type question in organic chemistry and one structure is organic chemistry. Target full marks. Why? In organic chemistry you find it you have to waste more time to earn that marks, because organic chemistry, no balancing, then no oxidation numbers involved. I mean they don't ask, and the physical state not considered, they don't ask. And the other one, you don't need to try the byproducts. So when you're going to balance, byproducts necessary in organic one, but organic ones byproducts not much important unless it is important for the identification of the compound. Other than that, we don't need to consider the byproducts. We don't write all the only the main product we write. Okay. Preparation of benzene. Ethine, I will show you how this happens. It's very interesting in that also. how ethane is for, that means alkyne can be converted into benzene, no? Alkyne. Practically you can do this in the, I'll give that flow diagram also. Okay, Ishara, when you're done, please tell me. Lower your hand. This is benzoic acid. I will write here benzoic acid. This is benzene diazonium chloride. Ethine, this is green art reagent. Sometimes I might give you a small test, not next week. You said that you need before the test to practice that again. Did everyone find it difficulty to to answer those questions today at the beginning of the session? Because that is important for the evaluation. Okay, Pramadi, okay. Okay, I'll keep this until you finish copying down. When you're done, please send message to the chat. Right, okay. Now, which part are you doing in the? Are you going chapter by chapter in the theory class? Which lesson you all are doing now? Inorganic, D block co, organic co. Everyone doing organic now. Theory class, raise the hand. Those are doing organic these days. Organic. You have finished the 6th lesson, 7th lesson started. Unit 7 started. How many of you? Ishara and Vinhara? Not yet. Organic. Ishara and Vinhara, are you there? Not yet. Vinhara also not yet, no? Okay. That means you didn't start even organic yet. A lot to do now. Or you skip that one and doing the other lessons, upcoming lessons. So maybe after 7th, maybe physical, I don't know. Anyway, your exam, sometimes they will have to postpone that also, but don't think about postponing the exam. You get prepared for next August, so you finish the syllabus. Then once they postpone by 2-3 months the exam, then you can definitely, I think your exam will be held in December. That is my personal experience. But this time batch also now is already postponed until November, so they'll have to postpone this again, because the teachers, the government school teachers are on strike. At least if they have done online, they will keep this at least end of November. But now I think sometimes that will shift to January sometimes, or end of December. If they have not finished the strike, they are still on the strike, the government schools and semi-government. And your exam now, I don't think that they will be in 2022 August they will be able to do it, but at least by December they will, depend on the situation within the next few months, the COVID situation in the country. But anyway, my advice, you get prepared, you finish the syllabus before next August. Then if you get, then that will be additional benefit you are getting, privilege. Then you can have 2-3 months to do revision of the entire syllabus. Otherwise, teachers, if they are dragging now, your exam is postponed, will have enough time to complete theory. And if they are dragging this until December next year, until the last minute of the exam, that is no point. Right? Okay, then let's move on to the next one. One more thing. That's all the reactions. Okay, now let's move back to the, I have given a paper last week, that organic reactions, past questions, organic reactions, we did only alkene ones we discussed. Okay, I'll share the screen. Organic reactions. Organic reaction types. Display. Okay, I'll share the screen again. Can you see the screen? Yeah, this one I'll discuss next day. I have to explain the one more type of reaction for this. This, not this one, I give homework, I think this one, sorry about that. That paper, the remaining question I'll discuss next day. Organic this one did you try the rest? Up to which question can you tell me, or up to which question we discuss? Yeah. First one we did discuss, right? Can someone reply to the chat? I gave this all the possible ones for homework here. Yes? Until the fourth one, no? Okay, bro. We did okay until first part, fourth part. Okay. The fifth one we had to do. Fifth one, fourth one did I discuss with you? Fourth one we discussed, right? Right. Fifth one, number 5. Number 5, how to convert this CH4 into CCl4? Can you remember the alkanes reaction? What is this? All 4 hydrogen replaced by? All 4 hydrogen atom replaced by what? Chlorine. So that is substitution. So what is used? Free radical or electrophilic or nucleophile? We use what is used? Chlorine. We have to use excess chlorine. More chlorine. Excess chlorine in the presence of UV or light, ultraviolet, or you can write just light within, if you want, if you write light also enough instead of UV. So that is free radical. They don't ask the name of this one mechanism type, but you can write if you want free radical. But is playing the MCQ also, the I asked meant to be the one free radical substitution. And CH4, what is the other one? That also free radical substitution, but there's a difference. There we use less Cl2, more CH4. So here use excess CH4 or more CH4, more hydrocarbon and less Cl2 and UV. Then only one hydrogen get replaced. It will not, the reaction will not lead until all 4 hydrogen replace. Okay. Actually this is single step reaction, but gradually we have to, because most important one actually organic conversions. You get out of organic chemistry you get more marks for that question, organic conversion one. So gradually we are I want you to come to that level, that standard. Without the reactions you can't do the conversions. And don't ever try to memorize the reactions. Some students, they wait until they complete organic chemistry and study the reactions and do the question. That will never happen. Organic chemistry, after every sections, one is you complete hydrocarbons, then you have to do that the questions related with that. Otherwise, after completing all 4 lessons, chapter 7 to 10, if you are trying to do this, then again you have forgotten the first 7th lesson reactions. So the reactions you have to remember by learn it by doing it, by doing the conversions, by doing the questions. Otherwise it's not practical to memorize the reactions and do the questions. That will not. Okay, then this one is what? Now you can see this there's a small correction here. This should be alkyne. This should be alkyne. Sorry about that. Can you please erase this? This should be hydrogen erase. This one hydrogen erase. This should be make it a triple bond. This is alkyne. Alkyne. Right. So how to eliminate HBr? That means you have to remove one hydrogen from this side. That means you have to remove HBr. You have to remove this from this side. You have to remove bromine. This side you have to remove one hydrogen. Then only you get the triple bond. That means elimination of HBr. How to eliminate HBr? Can I check the reactions of preparation of alkenes? I gave this. Under preparation of alkenes, I gave this. Elimination of HBr. How to eliminate HBr? Yes, what is the reagent used? Who can remember? we have to eliminate HBr to get the triple bond. What is added? What is the reagent added? That's what I'm asking. Check your summary, the preparation of alkenes. I give a summary preparation of alkenes, right? Previous class, last week. Anyone can remember? What is used? Alcoholic KOH didn't I tell? No. That is addition, Ishara. To add HBr. To add Br to what you are saying. I'm talking about the answer, the reagents that should be used for this one. Now we have to remove HBr. What is the reagent added? What is the reagent? Who will take away HBr from this? Didn't I tell this? Alcoholic KOH. See there, I have given alcoholic KOH under the preparation of alkenes. Alcoholic KOH. Yes, okay. If not, tell me. Alcoholic KOH I have given under preparation of alkenes. Alcoholic. Just write, I'll put ALC here. Alcoholic KOH. So we call it dehydrobromination. What is dehydrobromination means? Removal of HBr. Then this one you have to do two reagents you need. First you put palladium hydrogen with quinoline, palladium barium sulfate BaSO4, and then we put hydrogen, and number 2 we put dilute H2SO4. Actually when you put palladium BaSO4 H2, what happened? Alkyne become alkene, triple bond become double bond. After that when you put dilute H2SO4, water molecule is added. Both the reactions you have done. You have done this under alkenes and alkyne reactions. So actually organic conversion means a lot of reactions they come by in organic synthesis. When you're going to synthesize organic compound, then it's really important. There's the next one also. There's a triple bond that should be there between these two. Triple bond should be there like this. Triple bond should be there. Done? Okay. Now next one, acetylene C2H2. What is added? Can you tell me? Yes. Any volunteer? The next one, number 7, the answer. Yes. Okay. Winhar gave sodium. Yes. You can put sodium. Addition of Na. Good. You can put Na. Please write here in your the triple bond is missing here. It's a printing mistake here. Now reaction number 9. That means what is eliminated? Water molecule is eliminated. For here OH, here one hydrogen is going out. No, not from that side, the other side. Here one hydrogen is going out. One hydrogen is going out. Here OH is going out. That means elimination of water molecule. Then you get the double bond. So this also you have done under the preparation of alkene. Check the preparation of alkene. What is the reagent used here? To eliminate water molecule, dehydrating agents I told you. To remove water molecule from alcohol, you can prepare alkene from alcohol. This is a secondary alcohol. If you want to write here, this is secondary alcohol, because this is secondary alcohol. From secondary alcohol, now you want to prepare alkene. What is used? What is the reagent? Very good. Conc H2SO4. Or you can use alumina 350. Alumina or Conc H2SO4 can be used. Actually, Conc H2SO4 you have to heat out about 170 degrees Celsius. You have to heat this with Conc H2SO4 to about 170 degrees Celsius. But temperature is not very like necessary. If you write heat in that enough. If you put Conc H2SO4, that also it's a lot of energy. Then a water molecule is eliminated. It's a dehydrating agent. And after that, what is the next one? What is the answer for the next one? Yes. Next step. How do next step? Refer. Now refer the note. No problem. If you can't remember, refer the note. Refer the note and do it. Refer the note and do it until you are able to remember the reactions. Refer the theory note. Turn these pages and whatever this one you have the note, short note or resource book, and try to find the reagent. Then only you remember this. Otherwise, you will never be able to memorize all the reactions at once and do it. So here we can use Conc H2SO4. Right. Next one, alkenes. But okay, I can see the answers. Only Pramodi gave the correct answer. Pramodi, yes. Correct. Br2, addition of bromine. What about the others? Others didn't reply. Br2CCl4. Br2Cl4, CCl4. You have done this reaction. Only bromine, right here CCl4. Carbon tetrachloride also, because non-polar medium. Otherwise, bromine can react with water also. Bromine can react with water also. So therefore, it's non-polar medium. Because if you put Br2 aqueous bromine, then OH can get added here. That's why. Imagine in the exam, if you get here OH and this side Br, then bromine water. Then you have to put bromine water. One side bromine, the other side OH. Right. So that is. Then next one. Shall I erase this? Did you all finish copying down? Shall I erase this? Right. Then next one, number 10, last one. Number 10. Okay. You have to prepare. Okay. Now you have the final. This is how you get in the exam organic conversions. You are given the initial starting material and the final product. Now using these 3 steps, or how many steps? 1, 2, 3, only 4 steps. Using these 4 steps, you have to do this conversion. How to do this? First you have to add Br2. Okay, who can suggest? Okay, first you tell me that 1, 2, 3, 4 and tell me the things. You tell, okay, I'll put 1, 2, 3. You tell me what are the reagents. Anything? Any volunteers? This is how you get questions in the LOL paper. First one, what is the reagent? You put 1, 2, 3, 4 and put the answer to the chat. Or else you can, I'll give the permission to annotate on this. You can write. Enable annotation for the others. Right. I have enable annotation. You can now write, if you want on the screen, my screen, you can write what the reagent added. Yeah, any volunteers? What are the 4 things that you should, or you can put to the chat the answers. 1, 2, 3, 4. First step, okay, first step, what is added? Br2CCl4. Okay, very good. Who gave that answer? Tamasha gave the answer. Good. And Ishara and Pramodi also. Okay, very good. Br2CCl4. What is the next one? Then we have to write the product here. What is the product form? CH2, double bond becomes single bond, and Br2 is added. What is this mechanism called? Recall the mechanism type also with the reaction, then you will remember that. What is this called? Electrophilic addition. So and this is also known as test for unsaturation. Double bond becomes single bond. That means sp2 hybridized carbon become sp3 hybridized carbon. Hybridization changes, color change. Then the reaction is electrophilic addition, not substitution. Then second one, how to get triple bond. Triple bond. Yes. how to now you have to now you have to you should decide the first all the paths, I mean all the steps you have to predetermine, otherwise you get stuck in the middle. You should know from where you will start, and you should know your path, and you should know your destination. In organic conversions, now it's like this: if you are going a picnic, you should, you know your direction, right? You know, okay, first I will go to this place, and then from here to there, like that. You decide, no, you plan it. So when you are doing organic conversions, that is the, I mean, in highest percentage marks allocated out of all the organic questions, highest percentage for these organic conversions is structured. Is, I'll show you the past papers. You get like big flow diagram like this, blank edges and arrows. Sometimes they will give in the middle some reagents and the, or maybe the intermediate. So you have to decide. You can't just like, I mean, you don't know, you know the destination, you know the final product, but you don't know the approach or the route taken. So can you go a trip like that? Okay, you go to goal, and again you know, you think after going to the goal, you think where to go. So is that possible? No. If you are going the trip tomorrow morning, if you are going the picnic, then you decide before previous night, you decide, you plan it with the others. So this is our path. The organic conversions also like this. Don't write, don't complete the first sketch without determining the others. So you have to plan, from this I'll get this, from this I'll get this, from this I'll get this, like that. You have to plan it. Otherwise what happened? How can you erase? So after writing here structured essay, you can't write, you can't erase after writing in the first sketch. Okay, that's why if you are not sure, then the best thing is you can do with the pencil, because you get mostly this type of questions in the organic structured essay compulsory question number 4. Okay, new syllabus also get the same place. Right now, who gave the answer now? No. Before that, you have to remove. You have to make the triple bond. You have to convert this into a triple bond. How to convert this into a triple bond? You have to remove 2 HBr molecules. What is added? Alcoholic KOH. Very good, Tamasha. Alcoholic KOH. Done. Well done. Alcoholic KOH. Alcoholic KOH. Then what happened? 2 HBr molecules going out. Then only 2 hydrogen left. From this side also one H. This Br goes with this side hydrogen, and this Br goes with this side hydrogen. That means minus 2 HBr. Right? But don't need to show that in the exam. You will not get additional marks for that. Right? Okay. Then after that, next number 3, who can tell me the answer? Number 3, who can give me the answer? Number 3, yes. How to do the next 2 steps to get your final product? Yes. You can add sodium here. Sodium. Then you get what? Don't worry if you don't get. I mean, we don't. I mean, you think, okay, I can't do this. This is hard. No. This is the first organic conversion. So I will discuss with you. I'll help to do few organic conversions. Then only you learn the path. I mean the method. So here you get sodium. Only from the first one itself. If you can do this, I don't need to do this revision. Right. Then this is plus, and this is minus, and this is plus, this is minus. But anyway, in the exam, no need to put the charge. Sodium. That why this is because this is acidic. This is sp hybridized carbon atom. So sp hybridized carbon is more electronegative. This is electronegative. I put high electronegativity than the other sp2 and sp3. Therefore, this is called acidic hydrogen. This acidic. If the hydrogen is acidic, it can react with sodium. Sodium reacts with water, also releasing hydrogen gas. So this is called acidic hydrogen. What is this? If you want, can mark with a pencil, but in the exam, no need to do these things. Acidic hydrogen. So that is both the acidic hydrogen get replaced by sodium. Then what is the last one? Yes. Very good. Pramodi and Tamasha, very good. Add in CH3Cl. Excellent. Right. Add in CH3Cl. So gradually now you should learn up to now. This is a very simple one, but you get more hard ones in the exam. CH3Cl. So I'll start from 0. So first I gave single step reaction in this paper. Then I gave double step reaction. I mean the open one. Now 3 steps, 4 steps like that. Okay. Done. Okay. Good. If some of you have predicted this before me. So this is how you, I mean this type of questions very, very important, because more marks allocated for this type in the exam. Shall we do the last one also? Today we discussed this, or shall I give this for homework? Shall I erase this? Anyone still copying down this? Now today I did with you what? Organic, benzene reactions. So what is the catalyst used here? What is the reagent? What is the now AlCl3 CH3Cl already given. Today only you learn this. What is the catalyst here? Al anhydrous anhydrous AlCl3, right? Because it is not used up. I'll show you the mechanism next time. Mechanism, AlCl3 again release back. Actually CH3Cl, if you want, I'll tell this, CH3Cl plus AlCl3, you get this compound. Look at this, AlCl3, you get this one, CH3 plus and AlCl4 minus. Okay, now what happened, this CH3 goes with benzene ring by giving away this hydrogen. This hydrogen is lost. There's a hydrogen here. Look at the screen, you can easily remember this. Then what happens, CH3 combined with benzene ring. Now the benzene ring has hydrogen. This hydrogen combined with one of the chlorine and become HCl. Then you get finally benzene HCl, that means one chlorine going out here, and AlCl3 is not used up, it is returned as it is. These are the three things, and here you get a CH3. So CH3 comes to the benzene, and out of AlCl4, this hydrogen goes with what? One of the chlorine here and become HCl. HCl. Do you get it? Hydrogen get replaced by CH3. What will happen to this hydrogen? Hydrogen substituted by electrophile goes with whom? Chlorine of the AlCl4 minus. Then AlCl3 not used up. That's why it is called a catalyst. It is not used up in the reaction. So this is how you get structured essay. Again, what are the four things you should remember under organic reactions? Mechanism, type, main product, and the active species. So here the active species will be electrophile CH3 plus. So active species you should know, main product you should know, the reagents you should know, and the name of the reaction you should know. So for this reaction, what is the catalyst? Anhydrous. Yeah, most of you have put the answer to the chat. Very good. AlCl3. These are A-level past paper question. This is A-level past paper question. The one that I am doing now, 2003 or 4, the A-level past paper. In this reaction, ionic species attack the benzene ring. Benzene ring 5 electron cloud, rich in electrons. Therefore, CH3 loves to get attracted to the benzene ring. CH3 plus electrophile. Electrophile get attracted towards the benzene ring. Therefore, CH3 plus will be the ionic species. Then this attack is called what? Electrophilic substitution reaction. Now you can understand with this question what you are supposed to remember. Like actually in organic reactions, this is what you should know, these things. If there's a catalyst, the reagent, active species, the one who attacked the compound, and the name of the reaction, main product, if there's a color change or something, observation that you have to remember for the identification. Right. Then it's already 8:30, no? Yeah. So now it's not hard. My advice now, target full marks for the organic question. This one, mechanism. Oh yeah. Mechanism, this mechanism we did, right? This one we have done the mechanism. So third question have you done? Please raise your hand those who answer the third question. Now today you can do this also. This E6H6, what is the main characteristic reaction? Today you learned that, right? Electrophilic substitution, free radical addition. Then the B alkyne free radical, electrophilic addition, free radical substitution, and like that they can ask. So that one most of it done. So I'll discuss that next week. And this paper only this question. Yeah, this paper remaining questions try to complete. Then 2020 this paper you can't do yet. Don't do this one. The one that I'm showing now, don't do, because next week after my explanation you can do this possible questions. And 2020 paper we have to discuss inorganic and general MCQs. But before that I want to finish at least 50% of the organic chemistry also. That's why I thought of this before you do this in the theory class to the other places. Right. Okay, then we'll stop for today. And then next day also we'll do a Wednesday morning, then this time, right? All okay. So until even next day also we'll do the class, this time Wednesday morning 6 AM. Right. Okay, then have a good day and God bless you. Stay safe. Right.
Thank you, sir.
Thank you, sir.
Welcome. Welcome.